that a short bio about 50 words, presentation title, abstract, no more than
Oh yes.
200 words. Those presenting February 15th. But we can extend to, I mean, if it is necessary, we can extend up to March. So late registration, whatever you call it.
Okay.
And those who want to donate for the purposes, they can do that. I mean, at the conference, maybe. Um, Presentation.
Oh, we could even have a
Uh,
donate button on the website.
yeah,
That's a
that's a good
possibility.
idea. That's a good
Christian,
idea.
actually, that's another point. Christian is thinking about taking over the domain name of the website, right? Create
Uh,
a .org or something like that, and make it a bit more professional in that
We
regard.
have some HTTPS problems at the moment, which is not at all good for mobile users on iOS who get a black screen instead of the text conference invitation site. And this is a pure formal thing to get certain technical things right. I discussed with Christopher, but we don't need to extend that here. Just go ahead, and this is just technical. We find solutions for that.
Okay,
what
cool. Go ahead.
what Christopher has mentioned earlier also, there are a few other things. Branded bags, pens, notebooks. I don't know whether we need to have, or we can just give somebody maybe badges for us, but people in general, they write their name and stick, a sticker you can have,
Yeah, I
because
suppose
it'll be
you
hard.
know, like if people register, we'll have their name, and then you can just cross them off the list to say, yeah, you've arrived. It's still already know. But yeah,
Okay, so
it's worth doing maybe.
I suggest that you extend the registration to full name, address, email address, and everything, and not just I want to join because we have not enough data. Also, from data point protection, there needs to be added EU right law-wise a link to yes, we cover your data. This is stored, blah blah blah. We will have your cookies so that we are legally on the safe side, and all this routine stuff a standard web page needs to do when it presents in the UA in the EU. Please, yeah, for this.
Okay, well those are very technical details. Yeah, might want to discuss them again later. So
Once again, yeah, as said, this is just technical, but we have not to overlook that.
yeah,
yeah,
great.
but
That's great.
what I'm looking for is a lot of sites that Christopher you are given to go to different places, and the price. Um, yeah, so that's what I'm looking here. So let me see. Christopher website.
Mm, yeah, you can share the website as well, or do we need to? I suppose if it's going to be redone or relocated, I mean, maybe not. Let's see.
Oh, sent to me recently, right? I don't know why I'm not seeing it.
Oh, is this the email I sent you about the science fair?
Yeah, it's different places. Yeah, and the prices and things like that.
Yeah, it was just
Uh,
recently. Um,
Let me see. See, somewhere here should be there. But the idea is that, yeah, 1000 HUF is 2.6. So it is, and how the euros will be probably even less, right? Euros are stronger than even dollar, I think, more than. So
sorry, what? What do you mean?
the euros are stronger than,
The dollar?
yeah. Let
I
me
don't
see.
know. I don't know about that actually.
Why would that?
HUF to euro. Let me see. Okay, so it's 0.25. So me, so this will help us to get an idea of the cost.
You have to ask the hotel or the presentation and university room, should we get one? If you get an auditorium, that would be preferable, probably also from
Oh
presentation
my.
point of view, and by being staff members of physics and math departments present in the presentation and so on, having internal communication support by those should be able to get such a room, and not just for the thing of renting it, but by indicating that it is interesting for them to have us there. And the other thing is,
Ah,
when we get a pure hotel, you are on your own and you have to organize a conference. Hotels live from conferences. So this is not at all free just because you have a room there. You don't go down and ask, can I please have your beamer? No way. Okay? You pay for that. And how much exactly depends on the hotel. And it is more or less, as it's the standard income, main income, not the rooms of hotels, is doing conferences for them, including catering. These have some price tag you don't like to hear. So it depends on what you are able to organize upfront. If it's long enough upfront, if their rooms are free, not by reserved by other ones, and so on, then they are happy that they are not empty and give you a fair price, but it will not be free. This is the main reason why conferences organized normally are always tend to have a fee. Can be a small fee, like even a simple conference having with Wolfram blah 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 meeting in Europe costs about 1,200 euros. And you have additionally 100 euros for the room per day, 1,300 euros plus the travel. And that is not because the lunch is so expensive. That is because all the materials are prepared. People are working full time, have to be paid for organizing the conference and so on. And where you can save money is, of course, organizing it in non-profit organization style, as you do, Christopher and Rajan. And that is a large cost you can chop off from the 1,200 of a typical conference cost. But what you can chop off is what the costs in front of the 2 days of the actual conference supply, or 1 day absolute minimum, because you need the preparation time where you have already the room. You cannot prepare it in the morning at 6 when you make a conference at 9.
yeah. Previous night we have to get everything
You
ready.
have to organize the room. You rent the room a day earlier from lunchtime, and you give it back at least after the conference, either rather immediately, or if you have press covering there at the next day earliest, then that costs what it costs. And a conference room has a certain square meters, and logically, if you rent a room and sleep there, that has say 15 square meters or something, or 12 square meters. And if you rent a room with 250 square meters, you can think of it costs you 10 times more. And that is why that conference rooms, including catering, would cost 2,000 to 3,000 euros, should I guess, for
All right.
like that. And if you're 10 people and every one of us supplies 300 euros, then it's already paid. And the more we get back from sort of entrance fee would be good. But then we need also to, of course, cover a virtual entrance fee. And that's why the registration should be formal and not just, here's my email address, maybe I come, maybe not. And these are all things to be considered. Because in the end, we have the costs for the booking, and we have to pay them if the event happens or not, if the people get sick or not, if you join or not. You need to have an insurance that if something goes wrong, that the insurance pays for the upcoming costs, because we all got sick by something and still have to pay the hotel room. So all these things are a little bit more than a private meeting of interested physics enthusiasts in a hotel in Budapest. So I think you get the idea.
Yeah, that's a fair point. There's also like, yeah, but okay, so there's those practicalities that you're discussing, and I think they're important. But then there's also like, those are like high level kind of things, and then they need to either be met or if they're not met, then there's obviously a problem, which could imply that we might need to go a different route. You know, the way like, well, you know those videos where it's like, hack your life or something. I've forgotten how you actually say it. It's life hacks. That's it. Sorry. So like there might be some way to do this with zero money. Like,
if you find a way, I'm more than happy to follow. But I have my doubts, and you forgive me if I have severe doubts.
No, that's fine. But no, there's always a way to do things without money. But it's just whether you know whether you have the contacts or not. There could be like libraries that have rooms for free.
Yeah, that's true.
So there's definitely ways to go about it. Maybe because we have someone in Budapest, or Laszlo, you know people there, and they might have contacts that we can make use of.
Yeah, but Christopher, one might have contacts is not the proper order of reasoning. So the proper order of reasoning is I have contacts in Budapest, and hence we go to Budapest because that costs us much less than going somewhere else where we have to pay for. So this you shouldn't start a sentence the wrong way up. Yeah.
Well, I mean, yeah. This
Either
is
we have or we have not, and if we have not, then the
this is
hotel is the only option, and if it's the only
Yeah.
option, we have to pay for, and that's it.
Well, no. So yeah. So I think partly the reason why we settled on Budapest was because Laszlo is near there. In fact, initially we were going to go to where Laszlo was living, but so I think this is possibly a better way of doing it. I mean, and
Budapest is a great place, not to mismatch the idea. Okay, this is a really super good place, and the website starts out well, but it doesn't mean it is for free. And always this fear of something had cost is laughable. We organize something, we find a way to find sponsors. We have 5 months left or 3 months left or whatever. So we have to tackle the problem completely from the other end, completely.
Right.
But avoid cost and get money for it. That's it.
Yes. Okay. So that's okay as well. Yeah. I'm thinking of the worst case scenario, if you like, how to go about things when everything goes completely wrong.
No, yeah. Maybe we have to be prepared, I guess.
Meeting a camping parking place lot or something, but I would prefer a better organized one.
Same thing happens
in the park.
So I have found this to be true. I'm just sitting in my home, right? I'm not going anywhere. I'm all the time at home. I'm not going anywhere. Things can go wrong. So you have to be prepared wherever you are on Earth. At least now, you have to be prepared, because that's what's happening in the modern world. So I have found that not to be different. I'm not saying that other places we have to be vigilant and be careful, because there are things that we don't plan ahead. Things can go wrong.
That's
and
true.
We have to be things. But I found that that's true any place on earth, anywhere you go. That's true.
Yeah.
I'm just going every day to work and come. Something or other happens. I mean, not to me per se, but something happens around me, affects me also. So there's no day without incident, So that's what I found,
Yeah,
it just
but in
become
general,
world
things will go well.
yeah,
I'm not expecting anything major, like
Yeah.
upset or anything. And if we plan this right, and like Christian says, there's no reason why we couldn't afford to. Like, obviously, we're not going to have a tent in the park or anything. We're going to do it properly. So, but,
yeah.
I'm just saying the show will go on one way or the other. Like, so.
Oh yeah, that's true.
Okay.
Actually,
so,
we were So it is about 0.025 euro for one HUF. It's the same. I'm surprised that it's the same for dollar also. So it will be $1 to a euro now. So your dollar is stronger, I guess. I don't know.
Yeah, well, it's usually the case. Okay.
So and then let's go back to 1 minute. Let me get. I'm trying to get the ones that you have sent. Why am I not finding it? Somewhere here. Something. I saw that you have given a wealth of information. Let me see. Oh, did I cancel it? Oh. I hope I didn't erase that.
What are you looking for, Rajan?
Yeah, there are 2 emails that you send
Oh.
information about the
Yeah.
whole thing. I'm trying to see.
Yeah, it can be hard. It can be tricky looking for emails, can't it? Sometimes they can totally vanish.
Yeah, because I remove some of the draft, and sometimes it goes along with draft, I guess. I don't know. Hopefully it didn't. It's not supposed
Look up Hungarian Natural History Museum. That was one of the.
You have that email? The 2 emails you send me, you have that?
Yeah, I'll just send them on to you again.
Yeah, you can send to me right now. The 2 emails you send me. So I can
There you go. There's one. and then here's the other one with the science park. I'm just going to forward them again. I've also sent them to you, Laszlo. I think it is your. Yeah, I think I have your email address. So I assume that's.
Yeah, this is what Laszlo has sent. So Laszlo, your email is here.
Yes. You have it.
This is your email located in Debrecen governing body. I look for inquiry into management of an institute. This way circumstances being discussed. Okay.
Did you get
So
those?
I was saying, yeah, 1,000 HUF is 2.6 or 2.5. Now it's 2. Okay.
Did you get those? Did that send?
Yeah. So this is National Museum.
If you
So
want to
if you
share
go-
your screen, Rajan.
Yeah. Now I'm going to share. I
Okay.
want to. Yeah. Thank you. Yeah, I don't want to. Okay, let's go here. Okay, so you have the you are sent to me, and okay. So the National Museum. So this is the National Museum.
Yeah,
Seems to be good.
I think I got the name right. So as soon as
Hungarian National Museum
great.
and online tickets. I think we should be tickets. Full price is 3,500, which is about for $10. But everything adds up, so we have to watch out. But reduced price is. Oh, I should be able to get this price. 60. I'm more than 62.
Oh, handy. And maybe they got students as well. So
European economic country. I don't know whether they give for US. That's the thing. If I'm senior citizen, I'm not sure whether they
I don't know.
the US.
Maybe.
For adults, parents, coming to parents. So there's reduced ticket. We have to talk to them. But mainly it is a group ticket. I don't know whether they have group tickets.
Okay.
So I'm trying to see whether do we get like a package. Sometimes you have package like an ask to play package deal for all of them. They'll give a few of them, and the whole thing is probably I should go to AAA find out whether there's something like that.
Well, you got Discover Backpack Museum Garden Visit.
Yeah,
But
the
we
backpack Union Garden.
might not want something like that.
Groups between 1 to 30 person in a foreign language, a group ticket. So they got translators, 25,000. I would think it's 25,000. 25,000.
Guys, while you discuss these details, I researched in the Dean's hotel background information what possibly conference rooms would cost there, and the answer is 0 because they don't have some. Okay.
Oh.
The Dean's is a student, which is actually not at all bad to live there. The Dean's is a student accommodation with private apartments and community, and they have all the necessary $50 per day typical or 50 euros per day apartments, easy to rent, easy to go there. They are next to the campus, which is good, but then we would need a conference room at the campus because it's not a standard hotel. Not from what I can see at the moment, that you can even run a conference there.
Okay, great. Thanks for that. That explains why they didn't get back to me with any info on the conference room then. So another thing, if you go to the other email I sent you, Rajan, there's links for both the university, I think, and for science place. Yeah, that one, Science Park and the university. So we'll either hold the conference here. This will cost money.
You can ask whether they have conference rooms.
Well, I believe they do. You can find out. We can send them. I don't know if the website works that way. It's a pretty simple website. So you can kind of look at the gallery.
You must switch to English. It's.
You sure? I think it's in English.
No. There's a Hungarian flag shown.
Yeah.
above. Yeah.
I don't know, but if you press the
No,
Hungarian,
from the above of this. No.
yeah, but if you press that, does it not change to like Hungarian?
Here.
Already in
No,
English.
Go back. Go back.
No, just scroll up. Scroll up. Oh. Scroll up.
Oh,
Rajan.
No.
If you press the Hungarian flag,
You must close this and click down.
Just go back.
No, above the menu. You must go to the menu and the menu. Here. Stop. Dream NPC, and there is a Hungarian flag. You have a look. Yes, and you must switch to English.
No, that changes it to Hungarian though.
Yeah, yes, and yet now you can ask your question.
Yes, thanks.
Oh, I see. Thank you.
So, what do you think of that place? It looks pretty good.
Somebody can move on.
Oh, try it again.
I'm also having some cold and things, but I'm getting.
Oh, okay.
They're saying sorry.
Is Christian gone? You dropped it.
Yeah, somebody left or somebody came in. I heard the sound.
Okay. So
Thank you.
anyway, that's something we can look up. But I just wanted to show you the place. So that's it. I think there's some views from the inside. Yeah, and then there's also the universities. You can ask for a quote. You can look at that. Click that.
Maybe Google will find something.
Yeah, that might be a good idea if we Google it.
Oh, we can send a detail here.
Yes. Okay, and then there's also the university. I think I sent you a link for a university as well. The location is good. It's just down the road from where we are. It's like very central. And then,
It's not too far from where we are, right?
Yeah, and it's right next to the university as well. So
that's good. Ask for a court, gallery, offices. Oh,
so that's for offices. I couldn't find anything specifically about like conferences.
Conference rooms.
I'm sure they have.
We can send a request here.
Yeah.
It says request. Do you want to send that or do you want me to send it?
Yeah, if you want to do it, Rajan, go ahead, because I've got quite a number of things. You don't need to do it straight away. You could do it later. We might. What do you think? You're streaming all this. Don't do that. You don't want to share your phone number, do you?
Yeah.
Okay, do it later, and then continue on with some of the other links in the email.
So you are putting the email. Sorry.
No, that's fine. Yes. So the university and such, but so that seems good. We can contact the university as well.
Yeah.
Another stage.
Yeah. It takes time, but I think we are rolling. We have 3 months. The fast earlier we are, the better it is. So we get everything squared out by March or something. Then basically the basic things are there. All we need is that will be a good preparation. We have good preparation, and then by March we finish everything and we get the head count of our people coming from various. The local thing only we don't know, that we may have to wait till the time of the conference, but I think the head count of people coming from other places to Hungary, Europe, or I don't think Emery will be able to come. I have to ask him.
All right, fair enough.
Our own group.
And John, John.
Yeah, John.
Come in.
They didn't respond. I'll
yeah.
send them separate email, but
Okay, so we'll see. And yeah, but feel free to share us.
Ben Song, I don't know whether he'll come, but
oh yeah, he might. Oh yeah, but there is the option for people to connect via like live streaming and to present over the internet.
Virtual, the virtual. Yeah. Even Emmanuel, you're not sure. He didn't say anything.
So Wenzong would be good if he could live stream.
I thought Emmanuel will be somebody. Yeah.
Even and if John, there was a couple of other people as well.
Manuel.
Yeah.
Malavar won't be able to come, but
no,
I don't think he
probably not.
Venezuela
okay, so those are all good points.
But by March, first week, second week, we should be able to get an idea how many people are attending, because the conference room has to accommodate all the people. You know, you said about square feet and everything, so we have to ensure that. And then people coming from outside, most likely they should have a seat. You know, they cannot be standing or anything like that.
Absolutely.
I mean, some people take pride in the fact that we are standing only room, but I don't think we want to do that for people.
No, I don't think so.
Yeah,
people need a seat. Yeah.
But yeah. So like a town hall.
It's even tables would be good, because it's funny enough. Like when you go to these conferences, you often see people attending the conference, but they're just like on their laptops editing stuff. But I don't think that's going to be the case here. I think it's going to be more focused and laid back. It's not like people, although it does happen that people need to change things about their presentations before the conference. That is a thing. Yes.
You get an idea of the abstract. You know, I think after abstract, maybe we should have a time to send in the full talk by end of March or something, so we can get an idea of their transcript of the whole talk will be a good thing, not just abstract. So the transcript of the whole. Like Christian has said, then that will be helpful towards proceedings and things like that. Proper as a proceeding of the conference, you know. And then you say either ResearchGate or some other place like Christian was talking about. We can put that. So that will be our very first one. And the next one will be easier, I think. And a lot of things we will be squaring out in this first conference. And after that, wherever we choose the next one, after 6 months or 1 year, we'll be more prepared. We'll have better idea of how the logistic aspects, especially. And I think we'll be, by the time we get to each other, and then we'll have more sightseeing places. And then I think that's one of the attractions for me as well. Seeing places is very important. For you also, I'm sure.
There was the Hungarian Natural History Museum, looked pretty interesting. Yeah. University of Technology and Economics. That might be a good one, just from the point of view of a conference.
So let me show the other ones you have sent.
Yeah.
You have a bunch of things you have sent.
I think if you scroll up or whatever. Yes, this group here, there's the University, or the Hungarian Natural History Museum, then there's the University of Technology and Economics. There's a stamp museum, which actually looks pretty interesting.
You translate.
Oh, you can see up there at the top, we've got a choice between English and, oh yeah. Cool, that's it. We did it.
National Solar Panel Problem. So these are the students who are high school students, BME.
Yeah, the BME. So it seems to be a number of different universities in a very all close together. Well, there's BME, and then there's the other one that I had a link to, which I've forgotten its name. It's like ELE or something. I'll just check it out.
University events, equal opportunity. BME student recruiters visited Iraqi.
ELTE. ELTE is the other one.
Award for BME Nobel Prize winners. Oh,
Magyar.
in the modern physics, light bulbs produced.
You find. Looks like the other one works with botany, molecular, maybe bio
Is it
stuff.
biomedical?
Yes, that's. It looks like they do stuff like that. I'm sure they do other things as well, but education. They have a summer university.
Stamp museum. I don't know what that is. Stamp museum.
So this is the stamp museum. Looks pretty good.
Yeah.
I like their website.
Whatever you call philately or whatever, stamp collectors.
Oh yeah.
I used to collect actually when I was in graduate student, case student. There used to be a person who loves that, and I collect stamps for various countries, and we share. He was a World War II veteran who takes us ride in the university. There's a lot of interaction with him. So I used to be a stamp collector.
Yeah. Well, it was a big thing. It was a bit like when I was growing up, people were collecting poll cards and stuff.
Yeah.
Similar
Currency.
thing.
Now I have currency. Wherever I go, I have a sample currency from each country. I think.
Because stamps are technically legal currency, are they? Yeah.
Yeah.
And they can be worth quite a lot as well.
Yeah. Some of them go, I mean, I don't mean not lucky, but some of them are rare ones who go like 1,000, 100 or 1,000 times the value. So,
Right.
but I not be lucky in getting that. Really, again, we'll translate. Next session of the Stamp Museum. Philatelic Club. January 25th. So January 20, not renew. That will be over by the time we go there. But these are on January actually. It's all over. It's old stuff.
Oh, okay.
Then Castle. Oh, let's see a Castle.
Yeah, that looks really good, but the website is real. It doesn't really show a lot.
Sketchy. Sketchy.
Well, it's not. It just doesn't. It's not. It doesn't seem to be promoting itself very.
400 you have, at least you give the price of the tickets.
I guess. Yeah, it does. But it's not. It doesn't. It's not showing you like images straight up as soon as you land on the page. But it does look pretty interesting. Or it looks kind of. It's in the middle of a really nice park, I think so.
What is free entrance?
Oh, you can maybe about us. The castle will show you a bit more whether you want
to. About us.
Yeah.
They don't give the image. Oh, this is a castle.
Yeah.
Image of the castle.
Yes. So that's the front of it anyway. I assume there's more going on. So yeah, so those are just some ideas anyway, but it looks like there's an awful lot to see in the city, so.
It's a Renaissance Reformation age, right? Castle before Middle Ages. Wada Hood Castle. This is the other one.
All right, there are pictures from long ago.
Oh, the inside the dinosaur.
Oh yeah, there's also the Natural History Museum, which I would say would have better exhibits and that kind of.
Roebuck, Faithful Horse.
This is not the Natural History Museum, is it?
No, this is this museum.
The castle as well. Oh right.
Castle. Just the castle.
Oh yeah, if you can check out the Natural History Museum, that looks fairly impressive from my point of view.
Just
I think that's up. If you go to the top of the email. Yeah, the one you didn't click there, the natural hit. No, down. Yeah, that one.
now I like the fact that they give the prices. Sometimes it's hard to find out how much they cost. At least they're putting that.
Yeah, they're very straight up with their prices, all right. It's like the first thing you see.
Very true.
You can't
So
get
you
away
get
with the
a
prices.
pre-admission for visitor over 70. I'm not over 70, so I cannot get seat. Even then, I don't know whether they will consider.
Again, like there's no images. The first thing, like, you could have like
Yeah.
a eye-catching image, but I guess exhibitions maybe would be. Exhibitions is the next one. Permanent exhibitions.
Or that gives information.
Okay.
There
you go. There's
something it gives something about the old people. This is Neolithic.
that looks pretty interesting, actually.
Yeah. It's about old
Are they real skulls or?
aged dinosaurs, lost worlds.
Okay.
I don't know whether you find a lot of dinosauric fossils
That's a good.
there.
Yeah, that's a good question. I don't know. But sure, they dig them up in old parts of the world and then transport them over, or
At one point, I was quite interested in the dinosaur things. But
yeah, me too.
whales,
Well, it's still pretty interesting. You know, there's a whale, I think. Yes.
whale, yeah.
Yes.
Yeah,
But I think like there's factories over in China that make dinosaur bones and sell them to museums.
Oh,
Yeah.
not fake, right? Are they fake?
They are fake, yeah. Because that's what they do. But a lot of the exhibits that you'll see, if you go to a museum, like in my town, there's a museum, and if you go there, there's kind of an impressive looking dinosaur skeleton. But if you actually look and see, it's not real. Like the real skeleton is supposed to be in the back, you know,
Yeah.
carefully climate controlled, and then
Always.
it's just for display. So I don't know.
Let's see what this is.
Yeah, this is the art museum, which is probably pretty good.
Yeah, it'll be good.
So it's kind of different, you know. It's not focused on science. Different part of the brain.
Yeah, these are art, vision gesture experiment, Hungarian animation, under 11 years.
Oh, I'd say that'd be good. Hungarian animation would be interesting.
Director Gate, Pastor Attila. That's the same name as Laszlo, last name.
Yeah. Attila seems like a very famous. You got sculptures there as well, so I like sculpture work.
News. Virtual tours. Change now in virtual tours. They have virtual tours.
Oh yeah, I'll probably do the other one.
Workshop.
You can click on any of those to see the artists and their exhibitions. So this looks like contemporary stuff. If because these people look like
October 25th.
Yeah, well, it's an archive, so you can click on any of those, Rajan, and see what's
This one?
any of them. One that you think is interesting.
Let's see here.
Okay, so it's paintings for that.
Is it modern art?
Yeah, it is. That's modern art, man.
You have done some artwork, right, Christopher?
Yes. Well, art is a very difficult subject. It's got to be everything's got to be like Perfect.
Ah,
Well,
Terrible face of beauty.
well, that looks good. I'd say everything in this museum will obviously be very, very good. So.
Yeah. It's a new idea about all this. Corphalan, the wall of the times.
Yeah.
Ah, stone, wood, and metal. Ah,
Ottoman Park. Oh, there might be. Yeah. So that seems to be it. So they don't show you too much. It's just they're just posters for whatever is going on.
um, Janos. Yeah, living spaces. Oh, is he a famous artist?
I guess so.
Carolee Kraus. Okay.
It looks
Okay,
like I guess architectural drawings or something like that.
I wonder what the thermal bath is. Is it
Yeah,
spa?
it's just, I was just clicking randomly around the map, and I found like in this park area, I found this building with this like swimming pool in it, and I was like, "What the heck is that? That's so weird." So that's
Swimming pool, 26. They have also spa and things like that. I think they
yeah,
have spa.
it just looks unusual, like so. I thought I'd add it
Steam
in.
bath. They have steam bath.
Yeah,
Uh,
probably be for
like sauna. Maybe like sauna.
basically, yeah. There it is. There. I mean, it looks kind of impressive from a kind of historic architectural point of view. Again,
Bathmania.
not too many images. They need to like
Yeah.
hit you with an image when you come in, so you know what you're looking at.
Yeah. That picture is worth 1,000 words, right? So,
That's it. It's generally done when you're designing a website, but I suppose
they give some here.
they do.
Pools and saunas, wellness services, then medical services. And you have
Ooh.
Budapest spas, handmade soap. Wow.
I say the food is nice in Hungary.
Oh, I had to see that we get vegetarian. I eat
Are you a
mostly
vegetarian? Oh, you are. Yeah.
Yeah, yeah.
Is
So I
that a
hope
thing, Laszlo? Yeah, I'm sure it is.
pizza. Maybe I have to go if they have pizza. I can
Oh
go with
yeah,
that.
there's pizza. Right?
Or sandwich.
Yeah, there's
There
little
are
salads and stuff.
the other vegetarian things and
Caesar salads. Okay, well that's it. I don't know if you want to quickly show the website as well that we built, but or should we? Not do?
our website,
Yeah.
the elite.
Oh yeah, this is the other university.
Oh, this is the elite. It's
Laura
called.
and-
That's the university. That's a
Yeah.
university nearby. Oh, that's the university we are going to. The nearby university.
Well, yeah, we could ask them, or we could ask
Yeah,
the new ones.
yeah. If you want to explore that, Christopher, that will be great. Where
Okay.
we can fix our conference, reasonable price, reasonable. I don't know whether we can, like Christian said, there may not be anything free per se, but
It's
it's a
true.
low price. Labyrinthus. That's good. Labyrinth.
Yeah, I just thought that was interesting. It's some sort of cave system,
Ah,
clicking around randomly. Might not be worth the effort to go. Well, it might be though. Thanks. I think
so we'll go to our website.
But,
This one, right? This is the website.
yeah, so if you go to the landing page there, it gives you some information.
About, right?
Yeah.
So TechNet proud to announce first ever Text conference. Conference commence on May 29th. The consortium physicists from around the world who conduct research into various aspects, theoretical physics, and including quantum mechanics, cosmology, relativity, geophysics, and crystal constant. Purpose is to push boundaries of knowledge of the universe, to gain a better understanding of our place in it. Tech 25 will be held at Dean's home.
Okay, so
Hotel.
that's incorrect. That'll need to be changed.
Yeah, once you get the, you update this one based on the information you get.
Yeah.
Because this today, you say, I mean, we can probably, if it's too expensive or this thing, we can do the meeting in our room. I don't know it's possible or not, but the actual conference will have to be elsewhere.
Okay. Well, I mean, isn't the meeting and the conference the same thing?
No, the previous night, the 29th afternoon, we have, but yeah, we have a general introduction that you and gave, but it will be good to have the conference room that time itself.
Yeah, I mean, even if you were going to do some sort of meeting, you could do that at like a restaurant,
Yeah.
even a hotel lobby somewhere. Like,
Yeah.
perhaps,
Press release. The press people are there. On how fast they come.
So I'll need to get a profile picture for you.
Yeah, you have to change this one. You have to change, but I'll put the whole thing.
Yeah. Oh yeah, and I need to. I got the abstract from you, Gerd. I'll upload that before I hand over the website to. Oh yeah, it's just in future you'll have to send all your information to Christian because he's going to be the one who will update the website because I won't be able to do it.
So people can get here.
Yeah,
but Laszlo wanted
you should send it to Christopher, of course. My idea was just to set up a professional website with HTTPS as the service where it is currently registered in a non-profit way is not able to seemingly do that. And it's important that we don't get black screens when we are on whatever mobile iOS devices.
Right.
The conference.
So won't you need all the files, Christian, to upload them to your server?
As far as I can see, these are secondary questions. I can click a button and download the site recursively.
Okay.
This is. I will contact you with technical details on this. This is really just routine operation. Has nothing.
Okay. Yeah. Just email them to me then, and yeah. Okay, that's cool. So I'm gonna split off, guys, because I need to get some food. I haven't eaten.
Okay, great.
But it was
great. Yeah.
And
we squared out a lot of things, and then as time every week.
One thing I did try and set up a WhatsApp group, but I couldn't. I sent that to you, Rajan, but I could not. Yeah, I sent you an invite, but I don't know how to name it, so I might not be the best person to set that up. I don't know how. I just don't know.
Good. No, let me see whether I can do so. Let me check what you said.
But yeah, check that. Accept the invites, and then we can take it from there. Or so I'll see you guys next week, and send us any. If you have any questions or comments, you can email them to me.
Yeah, Christopher, I just sent you an email in the background. I will possibly follow up with a couple of non-solicited emails in the next days with what I can assemble together or think about. But I have not time to do that on the weekend, but we'll assemble that over typically after work hours from there and send you then.
Great.
Time. Yeah.
Okay, yeah.
And, you can send that video to Laszlo, and then you can use it. And the public, you can. The next week I have 15th. I will have the last episode of the history of physics. 10th. Emergent theories. So
will that be about theories on tags, or will it be a wider thing? Or?
Wider. So it's a general. I think we went through it. I think I have that here. Now whether you want to see it, you want to add anything to it, because I thought it will be a very general thing.
These are the slides for the presentation.
Yeah. So I can show. slides briefly. And if you have any suggestions, I can add to it. But
Use the
I don't know
bullet
whether
points.
it will be just an up thing that will help to.
Okay, so this is for next week, is it?
Yeah.
Oh,
So it
great.
is history of physics. I thought I will see the 10th episode, Emergent Contemporary Theory having numerical relativity. I don't know whether you might have seen this, Christopher.
Oh yeah, I did see this last time.
Yeah. So Emergent Contemporary Theory and citations. It's what I have now. Historical context,
Okay.
Albert Einstein's theory and early computation, breakthrough in supercomputers, key concepts in numerical relativity, T plus
Yeah.
one formalism. It's still a history. It's probably contemporary history, but
Yeah.
it is.
Hello. Would you please click on the height down beneath stop sharing? Yes. Now I can read the correct text. Oh.
Cool. So go ahead there,
Okay.
Rajan.
Detection of gravitational waves.
Yeah.
And then merger of neutron stars. Then finite difference. Numerical relativity, I thought was very interesting. You also presented one, right, Christopher?
Sorry, on what?
You presented something on numerical relativity. I mean,
Yeah, I did. Yeah, I'm still working on that in the background now. What I presented wasn't that good. It was like just beginning, but it's gotten a lot better. So
good.
Maybe I'll present the rest of it when it's closer to being completed. We'll see.
Technique.
There's still a lot of work that needs to be done on it. When I say it got better from its previous sort of terrible incarnation, it's now all right, and in the future it might be a lot better. But we'll see.
LIGO and Origo, particular observed signals. Then binary neutron star mergers, black hole formation. Okay. It's just a gravitational wave astronomy.
Yeah.
Simulating numerical relativity, somebody has curvature done this one.
Cool. Okay, so you need to add a bit more to that, maybe, but let's.
Yeah, you can say, should I add some more? And do you have any suggestions?
Oh yeah, suggestions. I mean, well, there's all sorts of things, isn't there? There's the amplitude-hedron. That's a relatively new thing that came out in the last 10 years or so.
Amplitude hadron? Oh.
Yeah, the amplitude-hedron. I think Sabine Hassenfelder's done a video on it. I don't think she was that impressed, just because it's basically just Feynman diagrams done in a different way or something like that. There's the new theory that your man did called timescapes, which basically says that recessional velocities are altered, or the apparent expansion of the universe is altered because of voids. Again, I'm not really that impressed, but it is very contemporary research.
About the dark matter.
I think it's something to do with that. Yeah, basically saying dark energy doesn't exist or something, or is it? Or it doesn't have. It's not accelerating anyway. And I think that's the point of dark energy, is to accelerate the universe. Are there any other ones? I mean, there's loads of them, isn't there? There's that guy's new research that talks about Markov chain processes as another way of explaining the collapse of the quantum wave function. He was that guy. He was on Theories of Everything with Kurt Jaimungal, and his name escapes me because he's quite a new, fresh face on the scene. I think his name is Bardon or something. I forgot. But you know him anyway. I'm not sure. That's all I can think of off the top of my head. But I'm sure there's plenty of others. And you guys could chime in if you have any other suggestions of contemporary sort of physical theories that you think are useful. I mean, in terms of like people who are kind of more fringe, you have Robert Bataille and his work on liquid sun. That's quite interesting. I don't know if that's really what you're going for, though. Is this?
Yeah, actually, I'm just looking at established thing.
Oh, okay.
Not looking at speculations. Like Vellamandas, he works with Emmanuel ESN recently, geometric diffusion or something like that, discrete geometric diffusion. So he say that Planck level, these are all happening at the, there are structures, lower decahedron, things like that. So it is a discrete structure, diffusion.
Oh yeah, he's the dodecahedron kind of. Yeah. He was commented on before here.
Just made a iSpace comment on the dodecahedron theory from the guy he's working with.
Yeah,
he's actually a very interesting guy. He's savant style person who has only 3 hours of sleep, not a day but a week.
Wow.
And,
whoa, really?
Yeah, indeed. Yeah, I had an exchange with him half a year ago about when we discussed relations, where he quoted iSpace theory in one of his papers, and he soaks everything in from other people's theories in like a sponge and spits out, and the next day a completely perfect formatted paper in 10 to 20 pages thing with a blink of an eye, and it doesn't even get tired doing so.
Wow.
He's really on super genius level. But the problem is he has a medical problem with being blood heart rate, of not sleeping, of course.
Yeah.
And every day could be his last one.
Wow.
So
Really?
that is interesting what he's right. But the dodecahedron theory he made, I had a look on from an iSpace perspective, and today commented on ResearchGate with an answer on his newest papers. And I don't think any geometric, be it dodecahedron or any of the, when you open Mathematica, there are about 2,000 names for geometric objects in the database.
Yeah.
Whatever they are line, shape, area, volume based in that sense, like spheres or cubes or what by folding to n dimensions. And of course, you can extend a cube in more than 3 dimensions if you know how to do that geometrically. It's more difficult to extend a sphere into or an unregularly shaped thing into n dimensions. But this is not what I'm doing in iSpace when I say 10 dimensions. What I have more super simple 6. D is 2 times 3D in parallel, not even intersecting. But that is another thing. So dimension is one thing. But when you go to a shape as your basis of your theory, then you easily overlook that there is no such geometry you're using. Either we have quantized objects or we don't, and if you believe that the quantum of time is derived by iSpace is another thing. But even if you don't, there is for sure no zero object and for sure no infinite object. For sure not, whatever the mathematicians may believe. And this is only in the brain. So when you do such a theory, which even with good results like theory of relativity, then you must be aware that this is an approximation. What you learn in school is that you do an oversum and undersum over a curve, which is exact. Like you have a sine wave, assume the sine wave is exact, and you do blocks under the sine and over the zero to approximate these. But when my theory of iSpace is telling me some direction and would be correct, then it's exactly the reverse. Everything is Lego style discrete, and the sign is the approximation. So when you have the proper graphical curve or volume or spheroid or whatever you geometrically can do with things like MATLAB and Mathematica to visualize that, you should always keep in mind that these are just in your brain. These are approximations. The real thing are the physical building blocks, because I think the quantum of time as predicted by iSpace will not go away. It will just not go away. Everything is so discrete as could be. And that means not that continuum theories are wrong. They're just very careful what they conclude, because the difference between a true continuum theory and a quantum theory is the following, and that should be in the history of physics paper of Rajan. When you have a pre-Max Planck time where the ultraviolet catastrophe was happening when you think of you have a small millimeter hole in an oven and want to see the spectrum coming out of there, and you calculate it with pre-Max Planck's equations, you get the ultraviolet catastrophe. So the curve is approximating correctly until a certain point, and then it predicts wrongly infinite energy. And as a baker in front of its oven in the morning, when it's putting out the pretzels out of the oven, it doesn't get killed by the infrared energy of the oven. We all know that. So the original theory pre-Max Planck with the ultraviolet catastrophe predicting was a continuum theory, and it was wrong. And then Max Planck thought about how to fix that and invented a quantum, and invented not just like iSpace, a radical quantum, which is time-based and quantizes everything, length, directions, mass, momentum, everything. No, even a simple quantum, and its worldwide accepted Planck constant h is a quantum. There are only multiples of that quantum in any theory whatsoever. Quantum mechanics, relativity is completely accepted, okay? And what did they change? So when you look at the curve, it means it goes exactly from the bottom to the peak temperature of the oven in that what you measure frequency-wise when you pinpoint the needle hole there, and then it flats out to the right down to zero. And what is the difference between the wrong theory, which uses a pure continuum mathematics, and the quantum theory? It was quantized a single entity, namely the amount of portions of energy you can shuffle at any given time. And that was only a single one. Now think what would happen to your continuum theories, whatever the kind, when everything is quantized. So that little transit from the continuum theory, completely wrong, completely bullshit, giving infinite answer, to a correct theory, what we can measure in the lab for the last 100 years, fixed everything by quantizing a single entity. And iSpace theory on constant of nature shows us, if you read and really understand that multiplication is not physics, but multiplication cannot be wrong either. So when you put 4 quanta in and get 50 constants of natures out up to the 9th or 11th digit precise, that is surely and hardly accidental. So we have a theory there which gives predictions. And that predictions are under the assumption that everything is discrete down there. Normal continuum theories, Hossenfelder style, don't like that because they would break their current relativity theories they love so much. But relativity is not wrong. It is just an approximation. And if you fix that approximation by the same method that Max Planck fixed the infrared catastrophe, you get closer to reality. And that is what I tell you. And if you have everything discrete to fix anything closer to reality, you in turn need to think about your geometry. Because in current 3-dimensional perception, when I look around here, I don't see pixels. And as you don't see pixels, there is a very, very small, and they're not at Planck length, or they are hidden in a subspace. And this is what I think is the correct answer. When you have a 6-dimensional subspace, you have a Calabi-Yau style 6-dimensional box, you get in 3D or 4D perspective a point particle. Because a Calabi-Yau space, per definition, if you think of it, people cannot imagine that. They say 6-dimensional, I cannot see. But what you can see is a Möbius band. And if you take a Möbius band as a 3-dimensional entity of a 2-dimensional plane, easy to be bustled by yourself with a newspaper, and children do that, cut that Möbius band in half, and suddenly you get these interwoven rings where they suddenly get in together. If you haven't done that yourself, take a glue, take a newspaper, glue it together, half turn, cut it in the middle, and see what happens. And if you don't think, wow, if you haven't seen it, you didn't understand nothing about geometry. And when you do the same thing, just logically, for a cube, you get that what I call a 6D iSpace cube, but this is nothing like a Calabi-Yau space. The right side is glued to the left side, like a torus ring. Then the top side is glued to the bottom side, and then what you cannot do in 3D is the inside is glued to the outside of such a geometric construction. And as typically the creator of the universe, the mathematics, or call it God, whatever you prefer, will not prefer the x-axis. Sorry, it will not prefer the x-axis. You have to play it symmetrically. And symmetrically means that you have x, y, and z axis, anti-y, anti-x, and anti-z. And anti-z is not minus z, and anti-x is not minus x, please. This is a new direction. And this is what the Calabi-Yau space means in current physics. Just the Calabi-Yau space is calculated by these people, if you know the papers of Calabi and Yau, with continuum mathematics. because they think it's cool, best integration theory is cool, best, but integration is just an approximation. What is really cool is integer theory. And that is not incompatible to relativity, Gert's work on metric models shows. Because I recalculated with iSpace Gert's models, critical parts, and wanted to disprove his geometry. And what I ended up with a deep bow in, wow, you do the same thing just with a much more complicated mathematics than iSpace. So that was really shocking, eye-opening for me that a 4D model or 3D model plus proper geometry, like in Gert's model, I think, can be fully compatible to something Lego-style discrete like iSpace. And that changed anything because the people out there don't believe that is possible. The most people in ResearchGate, I have the hardest time to talk to them, to tell them, no, this has nothing to do with constants of nature with the 10 dimensions. It's purely to sort in the Lego aspects, whatever that gives them as information. Yeah? The Lego aspect is crucial because the Lego aspect gives you a circular number of 3, and it's a discrete entity, and not 3.14 like you have from a current Euclidean circle. This is way different, and the people think all Euclidean circles have to be then 3, which is of course completely wrong. Because any geometric object you take and rotate, like, think this is a remote control, is a geometric object. And if I rotate that along its axis, at the border points of the axis, it becomes 100% Euclidean geometric circle. I could rotate it this way, or whatever way I rotate that shape. If I rotate it center symmetrically, it becomes a cube, or a ball. Yeah. So rotation of whatever geometrically shaped object around center axis gives Euclidean geometric objects. But that doesn't mean these Euclidean geometric objects are not comprised out of Lego cells. And the Lego cells in this way is the atomic area where everything happens force-wise. And that means also the forces are quantized there, which the Planck constant suggests. But no one is listening to that, including Hossenfelder, because they always want to save relativity forever. And that's the main point. Would Einstein be still alive? He had already abolished his own theory by now, with today's knowledge, understanding how wrong it is. This is just completely wrong, what is done there, not because of the geometry isn't working in a lab. So when you do theoretical calculations of practical experiments and theory of relativity, both special relativity and common relativity are giving correct results up to a certain point. And that certain point is about 10 to the power of minus 13 meters. And no one can go beyond because the constants of nature are known in iSpace theory more exact, but not by experimental results. So everybody thinks it will go on like to the power of minus 15, 16, 17, 18, 19. And here they are completely wrong. Because from 10 to the power of minus 13 meters and upward, there is a phase change happening. And physicists love phase changes from water to ice. And what iSpace theory is predicting is that we have a phase change on 10 to the power of minus 13 meter from a geometry of Euclidean P to a geometry of P3 is 3. In other words, a phase change from fine granular sandcorns looking like a continuum to Lego Duplo. And about the size is not too bad from a sandcorn to a Lego Duplo entity. And of course, you can make a Lego Duplo piece out of sandcorns. And it looks like a Lego Duplo piece. But you need millions of sandcorns to do that. And that looks like a continuum in our space. So this is how it works. And all the forces are, of course, electric. But I didn't want to interrupt Christopher with his numerical relativity simulation. It's just I wanted to give you an insight on how dangerous it is to think a continuum is a reliable calculation entity. Nothing against using integration graphics or differentiation mathematics for solving real-world problems. But you have to have, as a theoretical physicist, always on brain with an alarm button not to believe your results when they go to 0 or to near infinity. This is a super important point and should not be underestimated, because all courses you get when you train standard mainstream physics in university get taught by this would be the real thing. Just do your differential equation, partial differential equation. More, even harder math is better, and play around with the Schrödinger equation until it's squeezed out until you're dead. but it doesn't give you the real geometry. It just gives you statistical results. And these statistical results are because we have an ether there, and in the ether there are cells which are spinning, and these spinning at the border, like Emmanuel probably also with his theory states, are spinning with speed of light at the border, and possibly are embedded, which is just hypothetical, in even a superluminal sea of such cells where gravity is propagated in a superluminal way by gravitons, in the way envisioned by Emmanuel. And this is the way to go on a conference like TEX, to shape the border. We may not with everything in detail be correct with these things, but I believe what we have discussed in the last years is in general the right direction. It has to go away from this plain zero infinity nonsense to something ether style, physical, substantial, which is really there. And all the Michelson-Morley experiments falsifying that it is not there were indeed wrong themselves. And there is an experiment in the future which will come, which shows that, and that will be game over for anything there. And then we better be prepared with not being shocked. Oh, really? I had not believed this. In ResearchGate, about 10 to 20%, I'd say, believe in the ether, but the remaining 80 more behave like mainstream already, so that is not so much interested in discussing there with the persons anymore. When 10 years ago I did such discussions, there was 90% thinking that there is something wrong with mainstream. And why is that today? Did the people change the mind? No, of course not. ResearchGate grew from 100,000 top experts to 50 million nonsense physicists who just also there, who have also their ideas about whatever, but they're not very much special. So they just learned at school something and repeated it like a parrot there to be also present there, like in a social media system. But ResearchGate is not about, yeah, you're laughing, Laszlo, but it's really true. You're one of the, I recognized your work very early, and you have a really cool stuff there out. And that there are so few Laszlos and so many idiots out there in ResearchGate by now. And this is because when you put too many people into a group, and 50 million is too many, of course, then not everyone can be a genius. It's like unfortunately true. So they have a lot of average people there, and these average people are scared by hell that they would be told they did something wrong. So they are not progressive, they are not innovative, they are just the exact opposite. They are parrots because this is all they want to be. They want to show that they are able to do clever math. Yeah, good, but math is not physics. So we don't need parrots. Even Mathematica in the newest version 14.2 or even ChatGPT can calculate quite well. It is nothing special. It's like the people who believe chess is something special 100 years ago. Hey, the grandmaster of chess is a computer and not a person, because its ELO is way higher than the one of a chess grandmaster, which is about 3,200, and the computer can easily go to 3,800 and wins every single game. So unless you know what is really complex and complicated, you shouldn't believe your own words or ideas. What is really mattering is that you know what you are talking about and that you stick to it, whatever the idiots out there tell you. And I say idiots here in public, live recorded thing, because it is idiotic in research to prevent the existence of something. You cannot prevent the existence or prove the non-existence of something. You can only with an experiment verify something. And when you verify something, you have not automatically falsified something else. But some experiments are predicting, let's say, a voltage is between 1 and 2 volt, and you measure with 100 experiments, it is between -1 and 0.5 volt, then for sure this idea, this theory is excluded after them, because hundreds of experiments have shown that this model predicting 1 to 2 volt is wrong. And that is what is excluding itself. A model predicts something and is getting falsified. So you can easily falsify things, but you cannot ever verify things. And this is why the theory of relativity and quantum mechanics cannot ever be verified. They are just not completely wrong either. So that is what we know. But that is all we can say about. That doesn't make them, because they are just repeated like a parrot the last 100 years by Schrödinger equation, any better. They are lacking complete intuition of geometry whatsoever. And constants of nature are overlooked because 21 parameters are fed into quantum mechanics as input measured parameters. And ice-based theory is for the first time able to at least 16 compute exactly And you can, if you would like, put them in iSpace 3, put them into your algebraic equation and see what happens. But the people don't want to do that. And why is that? The more clever they are, they don't want to do that because they feel, oh, that could succeed. And when it would succeed, what happens? It would mean that iSpace has a clue by geometry, and that means not that quantum mechanics is wrong, it's just, in the sense, superfluous, because it's not telling the right geometry, it's just a model. But we're talking about not finding a model, but finding a real abstract representation for reality. And that is more than a model. And the question is how to prove that. And every model and theory has its own way of presenting its peculiarities, or I'm not sure the English word to say. So it has its advantages and disadvantages, to put it this way. And when some of the disadvantages of a model are open discussed, they can be an exclusion point for such a model or theory. You know, said you predict the sun is green. It's like, look out, it isn't. So model is wrong. And it's not always that simple, but it tends to go into the right direction. And with iSpace theory predicts a quantum of time. And that quantum of time is exact. And it's 10 to the power of minus 20 seconds. And the clocks are going better and better and better. And the prediction of iSpace theory is they will never be getting any clock tick beyond that 10 to the power of minus 20 seconds. To be precise, it is if you take the electron charge and divide it by Golden ratio ampere, you get a time in seconds, and that is the iSpace base time. And that is the maximum frequency of the 3D universe our atoms are made with, okay? Because atoms are charged entities, positive charged with electrons, negative charged. And whether the electron charges are just positron charges inside the atoms and doing a dance, or if quarks are real, that doesn't matter. It is giving a prediction that you cannot build an instrument where you, for example, in theory, would create a Planck frequency. What iSpace theory tells us, you cannot create Planck frequency, at least not with an electron. And this is a hard prediction. And when the clocks will be more precise, like with frequency comps, you get frequency comp by Professor Hensch, has invented the frequency comp, got a Nobel for that. And one of his scholars nested the frequency comps, that you take a single frequency of the frequency comp and made out of that single frequency another frequency comp. You get about 10 to the power of 3 more precision by such frequency comp. Now, when one crazy lab guy takes another of that right frequency comp and makes a third frequency comp on top of the first two, and it's just a matter of time until that happens. Could be a couple of years, could be 10 years, but in some point in the future, someone will triple cascade frequency comps. And then you have an electrical frequency of 10 to the power of minus 10 hertz, which is already electronically made. And then you put electric laser stuff out of there with that frequency, make frequency comps out of it, and cascade that, and you get about 10 to the power of 9 more frequencies. And suddenly you're in the direct range of the iSpace base time by 10 to the power of minus 20 seconds, which is 10 to the power of 19 hertz about. And once you have that frequency, you will see that the frequency comp, if iSpace theory predicts something properly, will start giving of the frequency comp to the right and suddenly just falls off. There will be 0 comps on the right side of the third frequency comp because the electron refuses to create the light you would like to see there. It's just not possible physically. And that is a prediction. And here you go falsify iSpace theory if you want. Show me frequency higher than 10 to the power of 19 hertz, and I retire. And that's it. Just wanted to give you an example how to make a prediction and what that actually is. A theory is then, and only then, a theory. Otherwise, it's a hypothesis if you have something to falsify. And that's it.
It's interesting. I mean, they have proved separately quantum mechanics and the theory separately, but when they put them together, it's a big problem. So,
yeah, it's a problem when you put the core, but we don't even know what the electron hull is. So how about sorting out the electron hull in the Schrödinger equation first is something reasonable? And the most reasonable thing, you can sort out the Schrödinger equation. By the way, for your history of physics program, Rajan, today I wrote in the NZZ, the new Züricher Zeitung, which I have an abo with. There was a very interesting article you might look on the New Zürcher Zeitung, nzz.ch also, whether you can read the article without being an abonnent. Otherwise, I can download the article for you. And
Yeah, can you send me?
I can send you if you want. Yeah,
Okay,
and it's about 20 pages, very well written about the history of quantum mechanics until Heisenberg nailed it, and what was discussed before in our style discussions, where people were a lot of discussing the right things and asking the right questions, but had no answers for. Why Heisenberg was the one nailing it was because he invented the matrix mechanics. And what most people don't know, have a paper of matrix mechanics of Heisenberg's, which was done by a PhD student, checking what Heisenberg actually did physically in this 2 week where he was on Helgoland and writing with a pencil and a paper and a short notebook, and he was sick with a hay fever and stuff. And so what could he have been done? He had not a supercomputer. He had all not this theory which we have today. So what he invented was matrix mechanics from scratch. But how do you invent matrix mechanics with a pencil and a paper? And the answer is with integers. So you have a magic square with 3 by 3, and in the magic square you write some integer numbers like 11, 12, 15, 3, 5, or some prime numbers or whatever. And when you build the matrix of that prime number, you see that a matrix, when you multiply it, has a virtual border to the right and a virtual border to the left, where the next row down is multiplied with the one row up when you left the matrix. But this is nothing like in a 2D game. So a programmer knows that well. I'm a programmer, so we know that well. When you program a UFO and you have that UFO dancing here, which you want to shoot on, and the UFO flies out there, the old games didn't bounce the UFO here. When you fly out there, you came suddenly in from the left from here. Yeah, but one scan line below, technically, from a raster point of view, because the scan lines on a PC goes like this. They zigzag over the screen to make your picture. Modern digital screens don't do that anymore, but the analog TVs did that exactly in scan line repetition. And the digital model of such a pixel system is actually quite suitable to view what matrix multiplication is at its heart. When you put floating point numbers in your matrix, you get a super, what is the right word? A super specified system, an over specified system. When you put integers in there, you have the absolute minimum information in that matrix. And when you are able to do quantum mechanics the way Heisenberg had done it at Helgoland, then you understand quantum mechanics. When you do quantum mechanics with Schrödinger equation, you just understand that you have a zero and infinity and a differential equation, which you are, as a cool mathematician, able to solve. But you don't understand anything of the physics anymore. What a pity. And history has chosen Schrödinger mechanics over the simplicity, much simpler to be handled for traditional physicists than matrix mechanics. It was alienating all the mathematic experts there. And that's why Schrödinger equation made an inroad into physics, whereas the matrix mechanics has been completely forgotten. But that invented quantum theory, and he used small integer numbers in 9 by 9 matrices. How difficult could that be? Okay, with a piece and a paper. And it resembles me much more to what iSpace is doing with its discrete numbers like 6961, and as a quantum number for time, and the pi3 being a circular number for running essentially in a hexagonal circle. And that is not at all rocket science. It's multiplicative, just as was Heisenberg's multiplication matrices there in Helgoland, but no one knows them anymore. And that little paper, which I mentioned before, just tried to work out what he thought when he was doing that, because historically that information has been completely lost and not understood. There are not good books about that, what Heisenberg really did. And after the invention of Schrödinger, he also not really offended. Yeah, so maybe he even gave in that Schrödinger is more elegant than his ideas. But from today's perspective of bits and bytes of computer system, Schrödinger's was inelegant, and the matrix mechanics of Heisenberg was the most elegant one. And it reverses the argument. Yeah, what is the approximation and what is the real thing? And most physicists believe, forgive me, Gerrit, that the approximation is the real thing, namely that zero and infinity and continuum and all the differential equations the real thing, and everything else in computers is approximized. But from a computer expert's point of view, this is completely wrong, because in a computer you have only bits and bytes, and all that bits and bytes approximate all your calculation numbers which you can ever have on a digital computer screen. And even if you build an analog computer system, which you can with operational amplifiers and things like that, sold it analog to an analog computer, basically. They existed at the time. Then you get all the errors. You get inherent shifts by being analog and not reproducible enough by being digital. And I always ask to these people, would I be the god of creating a virtual or real universe, and I would want to store my music? Where would I want to store my music, which I want to compose? Want to store it on an analog, perfect, mechanically, totally precise Japanese Sony Walkman? Or would I store it on an iPod, completely digital, where I can jump around and I would have no sound deviation whatsoever relative to the movement of the iPod? Whereas when you are going skiing and you have an analog, whatever precise battery charged Japanese Sony, you get, and your music gets frequency distorted because of the manual movements while you're skiing down a hill. So if you think that from a God creator's perspective, God isn't stupid in buying a Sony iPod, Sony Walkman, when he can have an iPod. So that same applies also for the real universe. God isn't stupid enough to make the continuum-based universe where everything deviates everywhere you look and have complicated mathematics and correction terms to repair it. He just makes it digital in the first place, where everything is exact and reproducible, as physics itself demands to be exact for the whole universe throughout whatever the time and whatever the geometric location. And I think this is the right direction to go when you think about it, even if you have learned different in school otherwise. Yeah. So it needs really to have a computer brain training or computer experience training to understand why that is necessarily the right path to take.
The computer is taking, like artificial intelligence. These are taking over everything. I think at one point they could be as smart as humans.
Not as smart, Rajan, but I agree as effective.
Effective.
They are not smart. Smart is the wrong word. Don't say smart in relation with AIs. AIs are dumb like hell, but they are extremely effective assistants for real clever people using them. For all others, you could also Google, because the answers of Google are likewise wrong in the first 20 pages. The correct answers are on page 21 and 22. And why is that? Because all the people not knowing the answer discussing the most, and this is the Google algorithm. Those most discussed is switched to the front. So in Google results, you typically, especially for physics, have all the wrong answers in the front pages, and the correct answers come from page 20 afterwards, where the experts discuss who have time to discuss that.
Okay.
And that is the real simple answer. And AI has learned everything it knows from Google-style answer pages, from typical people, and you can only hope that they have been hand-curated, filtered the most nonsense out, or when AI would learn from ResearchGate, God fear what happens with the next physics papers. Yeah, so it will just be what will be spit out there. Yeah, because on ResearchGate there is only 1 or 2% really clever stuff, and 98% you could delete and no one would miss. Yeah, this is just nonsense.
Yeah, actually, I found I used a little bit AI, and then I find that it spits out wrong references. So you have to really watch out. The
real problem is AI doesn't know when it's wrong. If you have two AIs and you make one AI surveillance another AI, then it can happen so with a higher probability that the second AI sees that the first is wrong. But think on the power supply necessary to do all that. You may not be aware, but a single request to ChatGPT 4.0 is about the equivalent of having run a PC for multiple hours.
Yeah,
just 1 question second is multiple hours of a PC, so hundreds of thousands of computing cloud hours in parallel to just answer something Google retrieves with a blink of an eye by a reverse index. So
it's a lot of
AI
power.
is not
You need-
helpful in knowing the obvious. AI can conclude things by reading a lot which you are unable to read because you don't
Yeah.
have the time to, or you will never
Yeah.
have in life the time to read
Yeah,
through.
it's too
And
much.
the AI is a very good worker. If you tell him to read millions of pages of paper, it does, and that's
Yeah.
it. And afterwards, it does just know more than you. And if you know more, the really interesting thing with intelligent people is they are not intelligent. They just have often done their homework, and hence they have more input for the same output. And when you ask a less knowledgeable person about a question and a more knowledgeable person, they are not more or less intelligent. They just have a better basis for the answer. And hence the person who has done more homework, sometimes the older persons, have just read more in their life. They know more by experience, and they come to different conclusions by having more input into their equation, what the output is. And of course, you might call that instinct, or you call that call it whatever you want. It's a matter of fact. And the AI is very similar to that, becoming more and more very experienced elder statesmen of trivia. And a lot of trivia can give quite intelligent answers. And this is a bit frightening how intelligent that actually can look like. But it is not intelligent, not at all. You can also ask the question reverse, Rajan. Are humans intelligent, or are we also just parrots being trained with the same? I don't know. I wouldn't discourse the ability that we are also not intelligent.
Yeah, it
Maybe
depends on what.
AI runs in our brains, but I think there's a different answer to that. Namely, there's a good paper on ResearchGate you should check up by physicist who also has a profession in biology, and he measured microtubuli under 4 Tesla magnetic field, and found out if no water is present, when no water molecules are there, when there is a dry probe, nothing happens. And when the probe is liquidized with standard H2O pure water molecules, then suddenly that probe of biological cutoff of brain structure from living animals, microtubuli, or human brains, from wherever you get that from, radiation is emitted from 34 to 45 terahertz when it is liquidized.
Wow.
And that is interesting because you're not yet in that frequency range for everyday's life, except maybe the 2 or 3 terahertz airport scanners, which can look through you. But this is not what is meant here. He's serious with that the brain is outside of the body, and the brain is just a radio receiver to the larger whole, because the radio frequency is immediately switched off when the water is okay. And he made a simulation what can create a frequency of 34 to 45 terahertz in biological material that you would expect in some quantum dotted silicon material or something. And even there, it would be very, very hard. So he found out that the microtubuli are carbon rings. They're exactly 12 carbon rings wrapped up to form a tube. And exactly one water molecule, one H2O molecule fits into one tube. You can put 2 water molecules next to each other in the tube, but assuming there is a constant flow in them, that a central H2O molecule is inside that microtubuli, then you reduce the vibrational abilities of water, which have modes in the V, modes in rotation, and so on. You stop all the rotational abilities of a water molecule by being in the tube, and you end up, the energy needs to go somewhere, and it goes into a high rotation speed. So when a water molecule enters a microtubuli, the theory is that it starts rotating with 35 to 45 terahertz. And that is a radio receiver with that frequency modulated directly in our brains, or otherwise there would be no need for the microtubules. And why I say that, when that would be a normal researcher with finding things and you wouldn't know what microtubules are, would say, yeah, let him talk. But the microtubuli book I have already become in form of Shadows of the Mind by a Nobel carrier, of course, Sir Roger Penrose. I personally interviewed him when I was young in the LMU University studying physics for 2 years. I interviewed him at the time when he was more a mathematician than a physicist he is today. and he presented the book Shadows of the Mind, why microtubuli in the brain are the core of human intelligence and thinking. And I still have that book, and it was a 30
Penrose?
years ahead of time. A 30
Is
years.
that Penrose? Penrose, you are saying?
Yeah, Roger Penrose, of course, yeah.
Oh, no, bro. Okay,
Sir
so
Roger, you know.
it's quite possible that our brains are like antenna. It's a highly complex antenna. That's all, because it's such a small thing, but it has all kinds of frequencies, antenna to delineate, to discriminate every frequency, and then
Yeah,
then
that
it
is
can.
why humans are different. People have some people like other people, some people dislike other people by instinct. When it comes, for me, it is the case. I'm not sure for you, but when someone comes in the door, I've never seen him, I immediately classify him as nice or being an idiot. There's nothing in between.
Oh,
I'm autistic, so you may forgive me that classification is not analog but digital. But in that sense, it is always working for me out well when I trust my stomach on this reception of what my instinct is telling me. I never went wrong with that. And how could I do that? It is not the eyes which see the person and see that there is idiot written on the head of a person or something, from my point of view.
oh yeah.
So that would be quite arrogant. Far from that. This is my instinct telling me I don't want to talk to this person, because if I would try, I would be disappointed and don't like him. And if I tried, I always was disappointed and didn't like him. So I'm really sure on that. And that means that something outside of our brain is connected together, a whole. Call it God, call it whatever you want to call it. A field.
Yeah.
And that field is the thinking field of a universe where we are only a materialized body, more a holodeck style materialized body, the receivers of impersonating us, as today in IT we call it an avatar. Yeah. So the resembling of current IT with that, what we see physically here, would be just a nonsense idea. Wouldn't there be the microtubuli and this experiment that there is terahertz radiation emitted? And now I do an experimental proposal. You remember we streamed that live for everyone, so that will be nailed. That I told you, you need to know that frequencies can be shielded, and sometimes lead shields proton radiation or other radioactive radiation, but there are metamaterials, and with metamaterials you can make weaved stuff. And one is a bag which you can put your iPhone in, and it immediately ceases of reception for all frequencies from 500 kilohertz to say 5 gigahertz, and it is offline. Thieves use this bag when you steal an iPhone to put it inside that it cannot be tracked anymore, because the iPhone otherwise spills out to other iPhones while the thief running away where he is. Yeah? So it can still be not tracking the phone running away, but tracked by the other phones where the thief runs by. And such a shielding bag I can envision for a terahertz radiation. You just need to find out how to 3D print such a metamaterial. And if you are able to do a metamaterial shielding for, say, 35 to 45 terahertz, then we can a super interesting experiment do. We sit in a nice, comfortable chair like you, Rajan, and put that bag over your head. And a millisecond later, you're unconsciousness. Then we laugh, we'll make a couple of nice photos, wiggle you on the chair that you're really unconsciousness. We put the bag away from you and said, what happened? Yeah? And that will be the proof. Because when our brain is just a radio receiver, you will be immediately unconscious. When
I think it's a transmitter, not a receiver.
Yeah, it's both. It's both.
Mm-hmm.
But the interesting thing, the professor, which I told you, I don't remember
the name.
He has made an experiment. He has put in the solution not water molecules, where with water molecules and 4 Tesla and the probe with microtubuli, you get this terahertz radiation, okay? But then he put a dose of a medicament inside that fluid, which would give you sleep while you were in a hospital. What is it called? A narcoticum, yeah? And with the narcoticum in the solvent solution, the terahertz radiation disappeared. And that for me was the proof. This is really like a proof. This is an ingenious experiment. It's an ingenious paper. It's all free available on ResearchGate if you want to find it. I have to see it is about 1.5 years old. And
you can send that to me also.
Yeah, this is give me time. I have lost it in my own thousands of
Okay,
documents, but it is on my
But the
cloud.
other one you have, like that 20
I
pages
have it.
you
I will have just to relocate and find it. I was,
Okay.
Rajam, I have already told to Christopher, I'm very sorry that I didn't attend to all the tax meetings in the last half year. Probably missed 10, 15 of it, but I was very busy day job working with
It's
IT.
all right,
And
yeah.
I was studying IT security actually at the high school in Hannover and made
Wow.
an official exam, which is now done. And I'm waiting for the certificate. I'm now a certified OT security expert, and that will be important in the future for my day job as well. But that blocked me off with everything else privately. And I will have a little bit more better coordinated time for physics again now in the next coming years.
Great. That will be great.
So
Yeah,
but think of it, when that is true what I told you, and have no reason to disbelieve this researcher, he hasn't invented it. Yeah, he's really a physics professor with a biological background, made this experiment and immediately published it on ResearchGate, and it cannot become better. Yeah. So like terahertz radiation out of biological system is already spectacular enough. And that is certainly a Nobel if verified, that terahertz radiation is something to do with the mind, because where is your mind when you're unconscious? So when you go to hospital and get unconscious, right? But where are you then? Yeah.
Yeah.
And that is
that's all
really the thing to think about. That is really, really cool path to pursue in the future.
So something happens to the antenna. The antenna can have
Yes,
different.
it happens to the water. When the water molecule is doped with these narcotics, the narcotics attach to the water molecules and they can't rotate fast enough to contact yourself, so to say. Yeah? This is what he found out chemically in the simulations.
Wow. Yeah, there are a lot of the
It's hard
brains
to argue with because it's facts based. This is real. Yeah, this is not some idea. They did it. It's an experiment.
Some people think the mind is the extension of the brain.
You can think what you want, but an experiment like that is nailing certain things what it is guaranteed not.
Yeah, that's true. Yeah, you have to prove it. Yeah.
I will find out when the paper is there and send to everyone a text group mailing list because that everyone, even interested outside of your theoretical own endeavors, whatever these may be in physics or otherwise, it is interesting to know something about ourselves and who we are and where we come from.
Yeah. More important.
I don't want to open a philosophical discussions here. That is just really all about currently frequencies and physics. We can have separate philosophical discussions with a beer in a suitable place.
Yeah. I plan to maybe there in Budapest we may have a little bit time to do that.
Yeah, I hope so. I really hope so.
If you have extra time, we can do that. But after my history, I think there are two things: history and religion, how it affected philosophy, how it affected, or how it promulgated the physics. How it helped as well as it hindered some ways. Because many people think, I think philosophy is important, like falsification, things like that, very important. Popper's idea, they are very useful. But I think we got away from it and went into math, which is hard to track. The math is, string theory, everything. And now more and more proof of the string theory is correct. But there is nothing to prove in string theory, and then very purely mathematical. Maybe some of it may be mathematical. These are things that will happen in the future.
Rajan, go and do with string theory, math, what I do in iSpace, and calculate constants of natures with it. And if you can do, I bow deeply.
I think I will say goodbye for today.
Okay. I'm very happy that we had that call today, and we have to do a lot of organization for that meeting. Laszlo, you are happy that I contact you over ResearchGate, or could you send me your private email address, please?
I will send you, and I would like to ask you something. I have
you can always do if you want. Yeah.
I have written an article about the ball lightning. And perhaps it's totally I don't know. But perhaps it's imaginary. Do you know?
You have ever seen in person a ball
and
lightning?
is near ready, and I think in 1 week I will put on ResearchGate, and I want to ask you to see that is normal or only imaginary, because I made on the page of the article what I written with the graviton.
I'm happy to help everything in the direction which you wrote so far, and I believe as you, and this is not just belief, I have, from my point of view, have hard facts why the graviton is real. And
because it's not with the philosophical term in context.
It's more than philosophical. It's more than philosophical.
In context, philosophical term of the Earth, because I think that the Earth is a because I didn't have another term, because our science has no proper term for this explanation. That's why I have to need to use the a priori entity. And this case, and onto this base, I have written the primer phase of formation of the ball lightning.
Yes, send me the link when you have the paper ready and uploaded, and I will try to get as soon as possible time to read it.
I would like to ask that I didn't write anything about what have others write. Only one I mentioned only the Chinese who have lock to observation before 8 years, and a Russian scientist who write 2 articles about the tip. How is I will send you today the Russian article and the Chinese article.
Go ahead. That is very interesting, and I think I commented today morning. It was pure coincidence. I didn't know that you would join the conference today. That
not important.
Is near ingenious.
You don't need to read it, only to know what is about.
Yeah, we all could try to, if we have the time to read, send it to the text groups or to private email address as you prefer.
Okay.
And, I'm happy.
Yeah, I send you.
I will send you my email address. Okay.
Thank you. You can send it by ResearchGate, that we have a better communication pattern over the web pages, always unhandy. Yeah.
Okay. And I have forgotten the test what you have seen today. It was tested in China, and I have log that it was a good test, positive test.
Out the experiment from the point, yeah, you didn't.
Yes, I have documented in 7-8 days. I tested with a simple test, and if we meet in Budapest, I will show you. I can present. It's a very simple. It's a very banal test.
It is not banal. This is ingenious. Ingenious and banal are 2 sides of the same coin. Okay.
It's very simple.
It's also simple, but it's not banal.
And I have worked in time of flying from China to Budapest. In 8-10 hours I was in continue working.
Wow.
Yeah, I'm happy that you had this result, and I'm happy for you, because the 3 conclusions in your paper which you made, which I read this morning, what should be and should be not as a result of that theoretical was a thought experiment. And you predicted exactly what the thought experiment's outcome should be. And I completely agree to your points. That with the weight on the high level, weight on the low level, horizontal bar, vertical bar, edit bar. So that is not rocket science, but it is ingeniously clever. And
Thank you.
It is. So I have to
Okay.
let the rest we can do by chat or by mail, and I try to see to give you the NZZ article, right, Rajan? That is what you wanted to
Yeah.
see for your history of physics. It could be really interesting to read into that.
Yeah.
Thank you.
Sure, you're welcome. Have a nice evening. Bye.
Yeah. So we'll
Thank
see you
you.
next week, hopefully. Yeah.
See you next week.
Yeah.
Okay.
Thank you. Yeah.
Thank you.
Yeah. Thank you.
Bye bye.
Bye. Thank you. Have a nice.
Thank you.
We'll talk later. Yeah.